Today we are going to discuss about the queue data structure. See, first a few discussions about the queue. Queue is also a linear data structure. Linear data structure means what? Just arrangement of elements side by side. A linear data structure. It follows a rule first in, first out. First in, first out rule it follows. Sir, how can we implement this queue data structure? What is the functionality and everything we will provide? First, few things about this one. First, few things. The first one is if you want to insert the elements, all are inserting from the end called array. Insert element from array. Next one, delete element. Delete element. That is from front. That is from front. That is. So deleting from the front, deleting from the front and inserting from the rear. But one very important point. This is index, suppose consider 0, 1, 2, 3, 4. 1, 2, 3, 4. This is front location. Imagine this part is very important. Front is always fixed. You cannot change this. Only rear only will move always. We always use two variables. One is a front variable, is always 0, of course. Next one is a rear. Rear is also 0. Front is 0 and rear is 0. Initially we are using. Sir, what is the size? Suppose I am taking one variable, size is equals to 5. The queue size is a the queue size is a 5. Suppose initially we are taking this one. Now the complete implementation I'll show you first. Then again we apply here. Parallelly I'll write the program. So what are the functions? Everything in a menu driven program while one condition is true. Condition is true. What are the operations? First one, which inserting the element. Insert. Second one, delete. Delete. Next one, third one is a what is the peak element? I'll explain all these things. Peak element. Next one is a pop element. Pop. Next one is a exit. Is nothing but quit operations. It's the same story. Just we ask, enter your choice. Enter your choice. Okay. So that we are reading. Scanf %d address of ch. We are collecting that choice. Int ch. We are collecting that choice. So based on the choice we are writing. If the choice is equals to 1, else if choice is equals to 2, else if choice is equal to 3, choice is equal to 4. If choice is equals to 5, if choice is equal to 5, simply that is exit na. Here just end of queue operations. End of queue operations. So no need to continue, just break. So suppose if they enter other than 1, 2, 3, 4, 5, other than 1, 2, 3, 4, 5, simply here it is invalid choice. Invalid choice given. So here based on that we are giving. So now the question is, now I'm writing one by one. How to do? The simple way of implementing this one. First one is a insert. Please write the function void insert function. It is taking what is the element you want to insert. Next one is a delete. So always front element only delete, na? So delete. Next one is a peak element. Is always front element only. It will give peak element. Next one is a display. Display or traverse. Anything you can write. Traverse. Next one, integer is full. Is it full? If condition is full, it will return 1. If that queue is not full, it will return 0. Next in the same way, is empty. Is empty. If is empty, return 1. Else return 0. Else return 0. This is the one we need to understand. Okay. The next one is, look at this. After this, all these things we need to write. We need to write as a prototypes. We know that. Okay. Void, delete, void, peak, void, display or traverse, integer is full, integer is empty. So what all the functions we are using, that we need to mention as a prototype. That we need to mention as a prototype. These are simply. Okay. Now here, one by one, I'm writing. First insert. So whenever they click on insert, here we are first reading that element. Enter element to insert. That we need to scan %d, that address of element. That variable we just declare element. Next one is we are just calling this function, passing that element as an input, element or data, anything we can call. Just calling that function, passing that element as an input. So control will come to here. But remember, whenever we are inserting the element, we need to check when it is full. So now here I'm keep on writing that code. Front is always fixed, but we are inserting using rear. Sir, suppose if I want to insert, okay, rear is already pointing to 0th location. You can directly insert the value 10. Suppose 10 I'm inserting. After inserting the value, increase the value. Next is are again inserting. Okay, into rear insert. After inserting, increase the rear value. Again into the second location, inserting. After inserting, increase the value. Now in the third location, we are inserting. After inserting, increase the value. Next into that location, we are inserting. Into that location. After that, rear value become 5. See, look at this. When size and rear both are equal, then we can say that it is full. So when you can say that Q is full? When you can say that Q is full? When rare value and size both are equal. Both are equal. Rare value and size both are equal. Then you can say that it is 1. So first of all, you need to create that Q. Here we are writing outside as a global variable int Q equals to Q of 5. Size also we mentioned. Size is a 5. Size is a 5. Not only this. Front is equals to 0. Rare equal to 0. Sir, why? These are all global variables. Global variables means what? You can access from every single function. Access, can access. Can access from any function. Can access from any function. That's why we are using that one. Remember, the 4 variables we have declared. So whenever rare value and size value both are, sorry, not empty, is a full none. Rare value and size value both are equal, then it is returning 1. Sir, is empty. Sir, when Q is empty? See, as soon as you have created, as soon as you have created, initially, what is the rare value? 0. Whenever the rare value is a 0, by that time, Q is empty. When rare equals to 0, we can say that Q is empty. It will return true and return 0 is a false. So whenever you are inserting if, we are calling is full. If it is full, calling the function, just it will return true or false. True or false. If it is full, from here we are calling this is full function. Is full function. Is it returning 1? No, because not at full, we keep on inserting. Then first store this element. Inserting means what? That element you have to place, inside that queue from the rare, not from the front. Remember the point. Whenever you are inserting, use the rare variable. Whenever you are deleting, use the front variable. This is the only way you can specify, okay, we are inserting from the rear or deleting from the front. That's all. So into that queue, just queue of rear, into that rear location. And after that, increase the rear value. After that, simply element inserted. Element inserted message. See, we keep on inserting. First 0th location become 1. Next 1 location become 2. Into second location become 3. Into third location become 4. Into fourth location become 5. When it is a 5, it will fail. It will fail. Then definitely when it is a full, it will return. Whenever it is full, it will return 1. Whenever it is a full, if it is full, we should not do this. If it is not full, we should do this. If it is a full, directly you can write the code Q is full. Q is full. That is, if Q is not full, else block execute. Then we are inserting, increase the rare value, giving the message. Element inserted, such type of messages we are providing. Okay, now This is insertion. Whenever it is delete, first of all, we need to check whether it is empty or not. If it is empty, how can you delete? We can't. Directly we can say that queue is empty. Queue is empty. Queue is empty. Then we delete. That code we will write. That code we will write. Then in peak also. In peak, first element, front element it is looking for. If it is empty, then front element is not there. If it is not empty, then directly peak element is simply queue of front. Peak element means what? Always front element. See, this is 10. It is not deletion, just printing. Just printing. But sir, in case of deletion, what we have to do? That is the story that I'll explain. Don't worry. Next one, sir, display. Same. If it is empty, queue is empty. Else, look at this. In this one, see, suppose always starting from the front, ending with a rare, but rare is a 5. It is pointing to fifth location. So rare minus 1 up to 4, you need to display. From front to rare minus 1. From front to rare minus 1. Here, few elements are just for loop we are repeating. For int I is equals to front, always. Of course, you can give 0 also, no problem. Front to rare, I less than or equal to rare minus 1 or less than rare. Both allow na? Both are same. I plus plus printf percentage d just q of I. So I value starting with 0. Q of 0, Q of 1, Q of 2, Q of 3, Q of 4. Like this, we keep on executing. That is the simple way of doing. Now, the only concept is what? Deletion. This is very, very important. If it is not empty, okay, directly we can say that deleted element is a front element. Deleted element is a front element. But maximum, everyone will do the mistake. After deletion, simply they will make the move this one, front plus plus. Front plus plus. No, that's not true. Only thing is what? See, general thinking, generally. This is the queue. Okay. Like any movie theater, a box office queue or any other queue, you just consider. Normally people will enter from the backside only, from the rear only. See, this is the ticket counter, consider. It's a ticket counter. So once one person got the ticket and the person left the queue. Normally what will happen? Will they move the counter? No. Simply the people will move the locations. The people will move the locations. That is, we need to do that. We need to do that. People will move that one. So 20 should come to here. 30 should come to here. 40 should come to here. 50 should come to here. Finally, rare should decrease. Rare should come to 4. This is. So remove that. In place of 10, 20, 20 place 30, 30 place 40, 40 place 30. Sir, okay. Sir, still 50 is there na? I already told you. It is impossible to remove the values which are present in the memory location. Sir, then see here, whenever you are accessing, we are accessing up to here. Next, if you want to insert into the rare location, we are inserting. Suppose 60, then 50 is replacing with the 60. Always we replace the values. You cannot remove the values. Okay, now, sir, how can we do this first? Tell me. So, for loop, I value starting from 0 or front, both are same, na? I less than rare minus 1. Why minus 1? I'll explain. I plus into q of I plus 1 will come. Q of I plus 1 will come. Finally, rare minus do. See how this code gets executed. How this code gets executed. Front means starting with a 0. 0. Rare value is what? 5. 5 minus 1, 4. Less than 4 means what? 3. So 0 is less than 3. Condition true. So I value 0, remember. I value 0. So 0 plus 1 means what? 1. First location element will come and store into 0. 20 will come into this one. Next, I plus. I value become 1. Here it is condition 1 less than 3. Yes, sir, condition true. So 1 plus 1. 1 plus 1 is a 2. Second location element will come and store here. 30 will come and store here. Next, I value become 2. Sir, here it is a 2 less than 3. 2 less than 3. So what is that value? Second, 2 plus 1 is a third location value. Is a 40 will come to here. 40 will come to here. Rare value is a 5. 5 minus 1 is a 4. Sorry, here it is a not 3, now 4. My mistake. 4. Okay. This one. Next one is a value become 3. Third location element 3 will is less than 4, condition is true. So fourth location element will come and store into third location. Next, whenever the value become 4, 4 is less than 4, condition fail. Because 4 plus 1 is what? 5. If you allow fifth location trying to access, why it is accessing fifth location? No element is there. Is a no element is there here. This is. So the only thing is what everyone is saying that even in internet also how they implemented the program simply front plus plus. That is absolutely wrong. Okay, this is only the problem in queue. That's why they introduced circular queue and double-ended queue. Those things also we will discuss in the coming classes. Okay, so what we have to do? We are shifting the elements for I starting from the front location, I less than rare minus 1, I plus into q of I. We are storing q of I plus 1. That's it. Finally, rare you have to decrease. This is very, very important. If you don't decrease, rare still pointing to 5 only. So every time you are getting that error is what? It is a full, it is a full, it is a full like this. So finally, executing the code, execution part. Enter your choice. Why it is executing old one? Still, oh, you are not calling. Insert. delete, display, peak and display. Na? Third one, peak. Fourth one is a display. Is a display, but okay. But it has to execute the current program only. No? Right. Insert, delete, peak, pop. Insert, delete, sorry, peak, display. My mistake. Now, see here, first we are trying to display, queue is empty. Trying to delete, queue is empty. Trying to peak, queue is empty. So we have to insert first. 10, 20, 30, 40, 50, 60. No, is not there. Queue is full. Now display all elements 10, 20, 30, 40, 50. Okay. Now here it is. I just want to delete 10 deleted, 20 deleted, 30 deleted. Now display only 40, 50 are there. Again 40 deleted, 50 deleted. Queue is empty. Nothing is there to delete. So this is the simple way of performing all the queue operations. All the queue operations. Okay. Please try to execute this program.